Okay, what we're going to do is we are going to begin the build phase of experiment number 3. And experiment number 3 is where we look at forced convective heat transfer inside of a tube. And so what we'll do, begin by taking our kit and pulling out the components. Now we will use the HTC2 in this experiment to be able to measure the temperature of our ice bath, so put that off to the side. And then we pull out our temperature sensors. We will only need 2 of the DS1s for this experiment. Oops, I just dropped that. They're falling apart. It's kind of cold in my studio. Temperatures are measuring about 10 degrees Celsius right now. And that's because in Calgary right now we're experiencing La Nina. And La Nina brings cold air because the currents in the Pacific Ocean have changed a little bit, and it brings us a lot of snow. It's going to be a low of minus 18 degrees C in Calgary tonight due to La Nina. Okay, so let me put that off to the side, and then let's dig into the smaller container. We don't need the cork nor the insulation. That was used in experiment number 2. So we can put that off to the side. Now, of the remaining PVC fittings, we need the valve. That's how we will control the flow rate in our pipe. We will need all 4 of the threaded couplings, so pull those out. We don't need the T-junctions, so we can set those off to the side. We need one 90-degree elbow. The other 90-degree elbow we don't need. We need a 45-degree elbow, so pull that out. We will need 2 of the 2-inch PVC fittings or pipes, so pull those out. The other things we need are the 2 4-inch PVCs with a single hole in them, so pull those out as well. The remaining components we don't need, so I can get rid of those over there. We will need both of the containers, the big one and the small one, so set that off to the side. Okay, now I had mentioned that we're going to use 2 of the DS1s, so which ones do you use? What I would like you to do is go back and look at your results from experiment number 1, where you did the calibration and the characterization of the DS1s. And I want you to look at the plot where you had T difference, T diff versus T av. And look at that for each of the DS1s and pick the 2 that had the difference closest to 0 between about 10 degrees Celsius and about 25 degrees Celsius. So you want to get the 2 sensors where it was closest to 0 for being the difference between that range. And because that will be the range for the experiment that we're conducting here. And so you want to have the DS1s that behave the best. And I did that, and for me that would be T2 and T4. So I'll pull T4 back and I'll pull T2 back, and then I can get rid of T1 and T3. We don't need them in this experiment. Okay, so we have our temperature sensors. We're going to put those off to the side. The other thing you need is you need cork. I have my cork in my pocket because I mentioned it's 10 degrees Celsius in here. And when the cork gets really cold, it's really hard to get over the threads. And so what we can do, pull out our grippy strips, and we will need all of the cork fittings for this experiment. So we'll begin by taking the threaded couplings. So we'll need 3 of those. We'll have cork placed on them. And what we need to do is if you notice in your kit, you have thick cork. There are 3 thick cork washers, and there are 3 thin cork washers. So we need to take 2 of the thin ones and place them on the threaded fittings first, and then take 1 of the thick ones and place that on the other threaded fitting. So 2 thin ones go onto 2 threaded fittings, and then 1 thick one goes on the 3rd threaded fitting. Now the process of putting this on, it's going to be a little bit frustrating, and the reason is when I developed the kit, I had actually cut corks that were, or washers that were larger of internal diameter, but they always resulted in leaking. And consequently, this is an interference fit. If you try putting the cork washer on the threaded fitting, you can't get it on. It's like, oh boy, this is bad. But in order to do it, first of all, you want your cork to be warm, not like 10 degrees Celsius, which is why I had it warm elsewhere. But what you need to do is just slowly work the cork down over the washers. Or not over the washers, over the threads, I should say. And so it's kind of a slow process. You use your fingers to do that. Sometimes you have to use your thumbs. So if you have strong thumbs, you can do it that way. And once you get it further down, you want the cork washer to go all the way down to the bottom or the base of the threads. And then that way you'll have a good seal for when you're conducting the experiment. And so once you get it down quite close, so there I'm probably, I don't know, probably about 3 or 4 millimeters, 1/4 inch from the bottom. What I'm going to do, I'm going to take the copper tube and I'm going to put it onto the threads. Now be very careful, don't cross thread when you're putting the copper tube with the sweat fitting, the threaded sweat fitting onto the threaded coupling. You want to gently bring it in, and if it's really tight, you know you probably got it cross-threaded. Don't cross-thread because you'll destroy the threads. And so as you bring it on, and then you'll start feeling more torque once you get to where the cork washer is. And at that point, if you want, you could take your little grippy strips and you can grab, I'm just doing it on the plastic part, but essentially what this is enabling me to do is to force the cork washer further down towards the base of the threaded coupling. Now I didn't get it perfect there, but that'll be pretty good. I think that should be good enough not to have too much leakage. And then the other two are going to be a little bit easier because we're starting with a thinner cork. So I'd like you to go ahead and put, so one thick washer on one of the threaded fittings and then 2 thin washers on the other 2. Okay, so there I have the thinner cork washers on 2 of the fittings and the thicker on the other. Now what we're going to do is, let's work with the smaller tank first. So this is the smaller tank which is going to house our copper pipe and it's going to go in the middle. These couplings, the threaded fittings, are going to go through the wall, and so we'll put one through the wall. And then on the other side, or the side inside the tank, what we need to do, we need to install the thicker washer. And so this is going to be a little bit more challenging because you have less access. However, once you get the washer on, and if you can see a couple of the threads, then that should be enough to be able to thread the rest of the copper pipe on. And so there I can see that I have a few threads exposed. And be careful while you're doing this because these plastic walls are quite fragile, and if you really force on them, you're going to crack your tank, and then you're going to have water everywhere, and your kit will actually be damaged, and it'll make it hard to do the remainder experiments. So on the other one, we take the other fitting. This is the other one with the thin cork washer. Exact same sort of thing. I'm going to take the thick washer again, and I'm going to put it onto the threaded fittings. And so you need strong thumbs for this. If your thumbs are kind of weak, maybe get somebody to help you with it. But you can see I'm starting to expose a few of the threads. If you can see 2 or 3 of the threads, that will be enough for you then to be able to put the copper pipe on. Okay, so there what we have the thicker washers are on the inside, the thinner are on the outside of our fitting, and now our fittings are held kind of in place within the tank. And it's at this point that what we'll do, we'll take our copper pipe and start working one of the fittings first. So what you need to do is take the copper pipe and place it onto one of the fittings, and then slowly turn, and again be careful not to cross thread. Remember I told you about that earlier. And if you want, you can take your grippy strip and use it on the tubes or on the fitting. So you're just doing one at a time. And once you've done that one, then what you can do is you can proceed to do the second end of the tank. And for this one, what I'll do, I'll turn from the outside. On the last one, I was turning the copper pipe, but now that the copper pipe is fixed on this side, it's going to be impossible to do that. So while we're putting on the other connector, I will turn from the outside. And I'm turning from the outside fitting using my grippy strip. And what you'll find is that your washers are now going to become snug, and they'll become snug on the base of that fitting. And so get to a certain torque where it gets really hard to turn, and then don't do any more. And then on the other side, let's see, how are we doing here? Yeah, that one seems pretty good as well. Okay, so there I have the cork washers installed. We are going to put ice in here, and that will give us a boundary condition on the pipe of 0 degrees Celsius. So we'll put that off to the side. Next thing that we need to do, let's work with the big tank because the big tank is going to be our storage reservoir where the water will be held at a fixed elevation, about 9 to 10 inches above the other one. And then that will then provide the head or the pressure in order to drive the water through the tube. So for this one, what we're going to do, this is the one where we put the thick washer on the base. So we're going to now put this, let's see, how do we do? Yeah, we want the threaded part to go out. So the threaded component on this one is going to stick out. With the other one, the threaded component went into the tank, but with this one, the threaded component is on the outside. And so with the threaded component on the outside, what you need to do is now work the thin washer onto the threads of this one. And again, you only need to push it on to the point where you expose maybe 2 or 3 of the threads. Again, be very careful while you're doing this because you don't want to damage the tank wall. The tank is plastic and it's a little bit fragile at times, especially when it's 10 degrees Celsius. If it's warmer, it's a little bit better. So what you do is you try to push it on so that you can, at least with this one, exposing, well, probably the first thread because we have the thicker washer on the other side, so it's a little bit more challenging. And then what's going to go on the other side of this is going to be the flexible hose. So let's take that, and what we'll now do is take our flexible hose and we can turn the fitting on the inside because it's still a little bit loose. Again, be careful about cross-threading. As you're going in, you just want to make sure that you are getting on the threads properly. And then what you can do is you can take your grippy strip, and what I'm doing is I'm rotating. I rotate the whole thing, and the you see the flexible coupling on the inside is rotating, but then I will hold it and then I rotate the outer hose progressively to make it tighter and tighter. And so that's the process by which you can get it to the point where you have a snug fit, and it seems pretty good there. You want to get this one fairly good because you might have leaks out of your tank. What you could always do when you're performing the experiment, and I saw some people doing this in early experiments, you can take your larger lid and you can put the tank in the larger lid, and then this will become like a containment berm in the event that you have any kind of leakage from the larger tank. So that is how we can use the lids here. Okay, that seems to be pretty good. So what I now have, I have the, let's see, I just loosened it a little. There we go. Okay, so now I have the larger tank with the flexible hose on it, and I have the smaller tank with the PVC pipe installed, and these are going to come together. What we're going to do, take your last threaded coupling, so this one does not have a cork washer, so we just put it on the other end, but this is going to enable us to go from the flexible hose into the PVC pipe. So it will connect like that, and we'll put that there. Now what we want to do is we want to take one of the 4-inch sections of PVC and stick it in the end of the hose with the hole aligned up, so that this is going into the end of our copper pipe where we had the fitting. and the hole is lined up because that's where we're going to put our temperature sensor. That will be the temperature in before the water gets cooled due to the ice bath. And that actually is just going to connect on to the other end of the flexible hose. And so that will be the way that those two come together. So this tank is now going to be higher and we'll have flow going through like that. And then on the other side, we want to be able to measure T out from the copper pipe. So put the other PVC fitting with the hole and have the hole mounted up, because that's where your temperature sensor is going to go, temperature in, temperature out, and those will be the DS ones. Now what we want to do, take your 45-degree elbow and put it at the end of that 4-inch section. So we have it there. Let me just put this one over here so that it's a little bit more visible. Wait a minute. No, we don't do the 45. Take the 45 out. I should be following my schematic, but I'm trying to go from memory, because what we need is we need the valve, because the valve is going to regulate the flow. This is a ball valve. You can look at it in terms of how it performs. Ball valves are nonlinear devices, so as you change the angle, the flow rate changes in a nonlinear way. So in order to get really fine adjustments, you're going to, once you get near the closed position, you barely turn the ball valve at all. And that's how you're going to be able to get a lot of data points as we do a Reynolds number sweep for this experiment. So we put the ball valve on. Then what we do is we take one of the 2 inches, we put the 2-inch on the end of the ball valve, then we put the 45. I was a little too excited about getting the 45 on there. We put the 45 elbow on, and then what we do is we take our 2-inch fitting and we put that here, and then we take our elbow. And what this is going to do, this is going to go into your kitchen sink. And at the bottom here, you're going to put your little yogurt container. And that's how we're going to measure how much time it takes to fill the yogurt container. Knowing the mass of water in the yogurt container, you get mass flow rate. And knowing the temperature of the water, you can get volumetric flow rate. So that's the way that we're going to, that's our flow meter, pretty low-tech flow meter. And then the HTC2, what we'll do once we fill this with ice, we'll throw it into the ice bath. That will enable us to measure the temperature of the ice bath. It should be 0 degrees C. And then the other thing, you want to take your temperature sensors. So here I have the DS1. So I will insert that one into the upstream side. And then I have the other DS1, and I will insert that into the downstream side. So that is essentially the experiment. Let me put this a little bit higher so that we can see kind of what it looks like. That will give us an elevated tank. That's where we'll put the water. It will then flow through the tube. We'll measure the temperature coming in. The water is going to cool as it goes through the pipe. And then we'll measure the temperature on the other side. Knowing the temperature differential, we can figure out the amount of energy that is being transferred. That then gives us the way of getting the heat transfer. We will assume that the wall temperature is 0 degrees C in this, because copper is very high thermal conductivity and this is very, very thin copper. So that will be the external boundary condition. And then we measure flow rate at the other side in our sink. So that's the experiment. So what we'll do now is we will go and we will perform this experiment.